Hello guys and welcome to my YouTube channel. So in today's video we shall be looking at a cover letter writer, right? So this is the user interface of the app. So we'll be looking at how we'll be able to build this in this project. But first of all, we'll show you how it will work. So this is what we'll be doing. So this is a cover letter writer that will help you to write a cover letter for any tailored job description. So you'll be able to upload your resume here and then paste the job description here, and then it will generate the cover letter for you. So this is a multi-step agent. Takes has different steps: the analyzer, the matcher, and then the writer. So let's look at how this works. So first of all, you upload your resume, okay, and then the resume is uploaded, and then we paste a job description. Okay, so and it's running now, so wait for it to get executed. So why is it getting executed? So what is happening now is, like I said, it's a multi-step agent. So first of all, it's going to analyze your resume and the job description, and it's going to match you. Now, matching is the agent will tell you your match, or whether the resume that you submitted is a match to the job description, or if it is not a match. So wait, and then we'll see the feedback. All right, so as we can see now, this is the feedback we got, that you are a match for this job description. Okay, so and then it gave the reason why you are a match, matching both the skills it saw in your resume and then the skills in the job description. Now, because this is a multi-step agent, I can give a feedback now to tell it to go ahead and generate the cover letter, or I can tell it to abort, or that it shouldn't generate the cover letter. So but here now, I'm going to tell it to go ahead and generate the cover letter. So, and it's going to go ahead and then generate the cover letter for us here now. All right, so as we can see, it generated the cover letter, and we'll have the cover letter here. So what happens here is, when we paste the job description, it's try to analyze both the resume and the job description, and then match, and then give a matching report. All right, so and then there was a human feedback. Okay, after the report, do you want to continue or do you want to stop? All right, so but we said I want to continue to build this agent. So that's why it generated the cover letter for this exact job. So we're going to be looking at how you build this agent. It's a multi-step agent. So join me in this as we build the agent. This cover letter writer, now we're going to split them into different agents. I'll be doing different work. All right, so we're going to go from, we have three agents. We have the analyzer agent, the matcher agent, and the writer agent. The analyzer agent will be able to analyze your resume and your job description, extract some important data from them. All right, extract important data from them. Then the matcher agent will be able to match your resume to the job description. All right, to be sure that okay, that this resume matches this job description, give you some details, and then you will be able to know whether you are a strong match for this job or whether you're not a strong match for the job. And then the writer will now be able to now write the cover letter, relying on the information that the analyzer and the matcher gave it. Now, it's not just the full resume and the full job description, but with a structured data that has been extracted from them. All right, so without wasting much of our time, we're going to jump in to see how we'll get this done. So first of all, we'll start with the analyzer agent. All right, so remember that the job of the analyzer agent is to extract structured data from both the job description and then the resume. All right, so but before we start building this, because we're going to build this after building in Jupyter Notebook, we transfer to Python file and then build endpoints that will enable you to access them. So we're going to be creating a virtual environment here now. Okay, so I'm going to open my terminal. All right, so let me increase my font so that you guys will be able to see my screen very well. All right, so then let me open up my terminal, and then I'll be creating a virtual environment for this project. So to create a virtual environment, I say python dash m then, and then the name of my virtual environment is my env. All right. So if you watch now, the folder has been created here. That's the folder of the virtual environment, and once it's done, then I can activate the virtual environment. So now to activate the virtual environment, I say my env slash scripts slash activate. All right, so I've activated my virtual environment. So what I can do is to change the Python canal I'm working with in the Jupyter notebook to this virtual environment. So here now, I'm going to come and then I will look for my virtual environment, my env. Look at it here now. So I will select this. All right, and then this virtual environment has been the environment on my Jupyter notebook has been switched to the virtual environment I created here now. All right, so I'm going to be installing all the different packages I'll be using for this project inside my virtual environment. All right, so I'll start by installing LangChain and LangGraph. All right, so I will install LangGraph now. All right, so I've installed LangGraph. Then I need to install LangChain Core and LangChain Groq. All right, so I have an error. Okay, let me take them one after the other. All right, then LangChain Groq. Okay, let me install Pydantic. All right, so all the basic libraries that I need has already been installed now. So I'll move directly to the code execution. So if there's any other library, we'll install it as it comes. So I'll close the terminal, and then we are starting with the analyzer agent. So we are starting with the analyzer agent. Now, like I said, the work of the analyzer agent is to extract meaningful data from both the resume, and then the job description. All right, so this is the schema to extract this data. So we're going to go over the schema one after the other, right? So this is a multiple schema. So in my previous videos, I showed us how you can extract a structured output from LLM. So I will link it to the description so that you can actually check it and then see how it can be done. So we are importing a list optional type dict annotated from the typing, and then from Pydantic we need the base model and the field. Now let's go down to this is the main schema to extract a structured data from the resume. So it is called the resume schema. All right, so these are the different data I wanted to extract. First of all, the summary, the work experience, education, skill, achievement, project, certificate, other sections, and then important keywords from the resume. Now we'll take them one after the other. All right, so the work summary is a string, just your summary, your professional summary on your resume. Then your work experience. Now your work experience is a list of all the work experience you have. All right, so when we watch it, you see that the work experience is a list of experience. All right, so experience is also a schema that we defined here. So look at the experience. All right, so you now see the different data that are supposed to be in each individual work experience, the role, the company, start date, end date, your responsibility there, which is a list, and then list of your achievement there. So you see that everything you did in that particular position will be listed out here. All right, and then the work experience is the list of experiences. So we'll be having a list of this. All right, so if you have 10 work experience, we'll have 10 of this. Okay, then the education is a list of education. When you come to education, you see that the degree, the institution, start date, end date, and then other details. So this is how the schema works. Your skill is a list of skills. We have what we call skill category. All right, so every category have a list of skills they have. Now when we check skill category, you see the name of the category and then the skills under it. So this JD will be able to do all the grouping for you. This schema will do all the grouping for you. Your achievement, list of string, all your achievements, the projects you've done, if there are projects, a list of projects. So this is the project, the name of the project, and then the description of the project. Your certificates, which is a list of certificates. You need certificate, you need the name, issuer, who gave you the certificate, and then the date. All right, then other sections, and then um, keywords. All right, so this is the schema to hold your resume. So when you pass your resume, it will be returned in this structured form. All right, where all the data is not just a particular string. Now all the data has been extracted from the resume. So that is this. Then let's look at the schema for the job description. All right, so this is the job description schema here now. So each job description must have a title, the company's overview, then the responsibility, the requirement, preference, or the requirement they preferred, company value, keywords, and then other details. Okay, so the job title is a string, the company a string, the overview also a string, and then the responsibility is a list of responsibilities. So this responsibility, defining each responsibility. All right, then the requirement, this is the requirement, the description, and then the category, the company value, preferred keywords, and other details. So with these two schemas, we'll be able to draft a structured data from both the job description and then the resume. All right, so we'll be running this code. So all right, this particular cell has run. All right, so we've built the schema for the resume, and then let's build the schema for the job description. Okay, and then we are done with this. All right, so I can get I can get the schema structure for the job description or for the resume. Just say the name of the schema, the model JSON schema. So if I run this, you'll be getting the full schema structure. So anytime we need to pass the schema to any of our prompts, so this is what we are going to be using in passing the schema to any of our prompts. All right, so this is what we are going to be using to pass the schema. All right, so we need to make other importations so that we can get going with our code. All right, so I'm here to install .env. So I come down to my terminal and then say pip install. So python.env. All right, so python.env has been installed. All right, so and I need to add my environment variable to the code. So I'm going to create an environment variable .env, and I'm going to pass my Groq API key here. So I've passed my Groq API key, then I can now build this. So this is importing OS, importing load.env from .env, importing the chat Groq. Okay, I don't need this. I don't need this either in our implementation here, so I don't need those. Then from LangGraph, I'm importing the graph, state graph, start and end, and then from the LangChain core messages, I'm importing the system message and human message. And here we're working with the OpenAI GPT OSS 120B parameter model, and then passing my API key. So let me run this. So this cell will take a while so that it will initialize the LLM. All right, then this is me defining the prompt. All right, so we have two prompts here. Each prompt, this one to load the resume and this prompt to load the job description. All right, so when you look at the prompt, you see that it is simple and straight to the point. Okay, you are an expert resume passer. Your task is to extract structured information from the provided resume. All right, and then few instructions here, and then we are giving it this instruction that is only the data in the schema it should pass, and then we are passing the schema. You remember when I showed you how we're going to be passing the schema to the prompt. So at this point, we're going to pass the schema to the prompt. Same thing goes with the job description prompt. Very straightforward. You are an expert job description passer. Your task is to extract structured information from the provided job description. And then here we are passing the schema for the job description. So these are the two prompts we'll be using for our analyzer agent, this to pass the resume and this to pass the job description. All right, so here now we are creating a structured LLM, an LLM that can give us a structured output. Okay, so the resume LLM, which is LLM that we structure output, and then we are passing the resume schema, all right. So this particular LLM will return a structured data as this schema that will pass, which is the resume schema, and this will return a structured data as this JD schema. So in one of my previous videos, I also taught how you can extract structured output from LLM. So I think I've said that before. So I will link it to the description, and then you'll be able to learn how that is done. Then this is our analyzer state. So these are state schema, the state schema that I'll be working with the graph. Very straightforward. What we need in this particular state for this particular agent is the resume text, the job description text, then the past resume, and then the past job description. All right, so the past resume should be an instance of resume schema, and then the JD should be an instance of the JD schema. Just very basic. All right, so we'll run this and then I also run this. Okay, so now we'll be defining the graph here. It's very straightforward. So we have two nodes, the um, resume node and the JD node. So this node will pass the resume and this node will pass the job description. So let's look at it and see what happens there. You see that each of them takes the state schema, which is an analyzer state, and this will also return the analyzer state. All right, so what we need is to first of all construct the system message, okay, which is a system message, and then the content is the resume prompt.format, and we're only populating the schema because that is the only key we'll have there to populate, and the schema is equals to the resume schema.modern.json schema. All right, we're passing the schema the way it is to the prompt, and then we're constructing our human message. So the human message is we're passing the resume text, and we're not saying that the resume text is state of resume text. So we are extracting the resume, this key now, from the schema when we'll pass it, and then we'll pass the resume text here, and then we'll be able to now invoke. All right, cool. So we are invoking with both the system message and then the human message. So when we invoke the response, we are updating the past resume with the response, because this LLM is going to return an instance of resume schema, and then we are updating it with the past resume. All right, so the same thing happens with this node that is passing the job description. Okay, we'll get the system message passing the JD prompt.format, and we are populating the schema, the only key that we have there, with JD schema.modern JSON schema. All right, and then we're also getting the human message. We are passing that the job description text is, we are passing the text for the job description. We are getting it directly from the state schema. Then we invoke and then we update the past JD with the response. Remember, this response is a structured output of type JD schema. All right, then we get over here to do what? To build our agent. All right, so we are the analyzer builder from the state graph, and then we are passing our state schema as analyzer state. All right, then we are adding our two node, which is the past resume node and the JD node, and then we are now building the edge from start to pass resume, from pass resume to pass JD, from pass JD to end, and then we are compiling. It's very basic and very straightforward. All right, so let's print the graph, and then let's see how the graph is. So this is the graph. Very straightforward. When we start, it gets to the pass resume, from pass resume to pass JD, and then it will end. Very straightforward. All right, so first of all, this is the job description. Okay, so it's a role for AI engineering. This is the company, the location, the department, the employment type is full-time, and then this is the salary expectation, and then this is the job description. All right, so the job description, and then the requirements, and all that details that is being needed for the job description. So this is the job description. So we can run this, and then we're going to load the resume. All right, so the resume is here as a PDF file. I have a folder here that is having the resume.pdf. Okay, so the resume is here. So I'm going to link in the description of this video, link of this project on GitHub, so that you can actually access all the data that we need here. So we need to install the PyPDF. We don't have it installed yet, so I'm going to install the PyPDF. So pip install PyPDF. All right, so we'll have the PyPDF installed now. So we can now run this code, and then we'll be able to read the resume, which is the PDF file. So we are passing the file type, and then reading the file, and then iterating between the pages to extract the text in each page. All right, and then it's being held by the resume, this variable here. So we run this, then this don't run, and then we can print the resume, and then this is the full resume. All right, so this is the person's name, Felix Adebayo, stays in Lagos, Nigeria, email, phone number, and all the details. This is the professional summary, this is the skill, and then this is the professional experience, and we'll have the certifications and every details that are being needed in the job description. All right, so we've gotten the resume as a text, as a string in resume here, and then the job description in JD. So it's now time to invoke our graph. All right, so to invoke our graph is just to say the analyzer graph.invoke. All right, and then the input, we need to populate two important keys, which is the JD test and the resume test. All right, so we are populating the JD test with the JD and then the resume test with the resume. So we run this, and then we're going to get the results in this result. So let's run it. Let's run this now. All right, so this is done running now. So if we look at results, okay, so that we'll see the keys that are returned with results. So you see that result now has past resume and past JD. So these are the two data that we are interested in. All right, so if I check the result of past resume model dump, so I can see the entire data that was returned there. So you will see a well-structured data about the resume. So this is the summary, this is the work experience, these roles, you will see the different roles that the person has done. This is education, degree, skill, category, and all other details are being captured here. And it was neatly captured. No more bunch of tests that the LLM will be struggling to get different data from. So as we go on now, this past resume is what we're going to be making use of in both the matcher and the writer agent. So this is what we're going to be making use of. All right, so and then let's also look at the um, past JD. All right, let's see how it is. So this is the past JD, and then the same way that it got the structured output from the past JD. So, all right, um, with this now, we've been able to extract structured data from both the job description and then the resume. So let's now go straight to the matcher agent. So the main work of the matcher agent is to match between the job description and then the resume to see if the resume actually matches the job description. All right, so this is the main schema of the matcher agent. It's called the match map. Okay, it has the overall score, all right, from 1 to 100 of your strength. Okay, this like, okay, your resume matches the job description 10%, it matches it 20%, it matches it 100%. All right, so it will now get a list of your top matches, the gaps that you have. Now the essence of these gaps is so that you'll be able to go and maybe probably see a way to fill them up if you're actually interested in that role. So this gap is very, very necessary. So see this as a way of matching to see if you actually meet the requirements. All right, and then telling you where you need to work on. Okay, we'll have the keywords that are missing and then the keywords overlap. Okay, so this is the matcher agent. All right, and this match item is under the stop matches. Okay, it's under the stop matches. It tells you if you actually matched. Okay, the match item, the category, resume evidence, and then your strength, and then the reason why probably it did not match. So and then we'll go ahead to run this. So and then we'll go ahead to this is the prompt for the matter. All right, so it's very straightforward. I don't need this, so I'll take this out. So this is the prompt for the matcher. So very straightforward. You're an expert career coach and ATS optimizer specialist. Your task is to compare the past resume with past job description and create a precise honest match map. All right, so and it's giving it all the details it needs, and we are passing the schema here. All right, we are passing the schema here. So this prompt, we're going to be using this prompt to pass the human message. So all we need to pass here is we'll pass the resume and then the JD. That is the past resume and then the past JD. All right, so let's run this. All right, then here now we are getting um, so we are getting the structured output. So the LLM with the structured output. So we run this, and then this is the schema for this. So in this schema, we're having the resume test, the resume job description test, and then we are still passing both the past resume and the past job description. All right, so we're going to be passing them there, and then the match map, which is a type of match map. So we're going to run this now. All right, so um, to run this, we're going to build the node. So the node is still straightforward. We construct the system message and then the human message. All right, so the system message is taking the matcher system prompt and then it's populating only the schema. All right, and then the human message is taken from the matcher user prompt, and then we are populating the past resume and the past JD, and we're getting all this from the state. Okay, so we need to pick this from the state, and then this as well from the state. All right, we are picking from the state which will pass to this node. Okay, and then we are invoking. Remember that this particular LLM is going to return a type of match map, and then we are populating it to the. We are updating the match map with the response. Okay, so this is the graph. The graph is very straightforward. We have only one node here. Okay, which is the matcher node, which is this node here now. So we are going from the start to matcher node, from matcher node to end. We are compiling and then we are displaying the graph. So let's run this. So this is the graph, very straightforward. Now we can now build our agent. So this is data we want to pass to the agent. All right. So we need to pass both the resume test, the JD test, the past resume, and then the past JD. Though the two data that are very necessary is this resume test and past JD. So if you didn't pass the resume test and then the JD test, it will still work very well. All right. And then where are we going to get this past resume from? So we've run the analyzer agent here now, and the output is in this result. So this result is holding all the output of the analyzer agent. So anytime I want to get the data that are from the analyzer agent, we'll be calling this variable result. Okay, so we'll come down here now to display. So that's why we're having the result of the past resume and then the result of the past JD. All right, so like I said, these two are not compulsory. You can add them and you can skip them. It will still work very well. Okay, so then we are tagging this one result one so that we won't be able to overwrite this. Okay, and then we are saying the matcher agent dot invoke, and then we are passing the input. So let's run this. So this is done now. So our JD and job resume has been matched. So let's look at the result we have here. So let's look at results one. So you see that now the match map has been populated. So we should be interested in the match map. So if we run this now, so this is the match map. So let's screw up and then we'll see that this particular resume has a 85% overview score. All right, so that means the resume is actually a strong one, and then it was able to list all the top matches from the job description, all the gaps. So these gaps are the little details that are not in the resume, but they were in the job description. So these are the gaps, and then the basic keywords that exist there, and then these are the missing keywords, the efficient model, and then GAN. So you see that the resume and the job description has been matched, and then the resume is having around 85% score, meaning that the resume is actually a strong match for that particular job description. All right, so this is the matcher agent. Then let's go straight to the writer agent. So the agent that will be able to write the cover letter. Okay, so this is the writer agent. So this is the cover letter schema. Okay, so this is the full cover letter. This is the word count. This is the use keyword. So all these details are necessary if you actually need to make use of them individually while you are working. All right, so and then this is the schema for the cover letter. Okay, so this is just the schema we've been working with, which is the resume test, job description test, past resume, past JD, match map, and then we've now adding the draft letter. And inside the draft letter, we should be interested in this full letter, which is a string. All right, so I'm going to run this, and then let's move forward. This is the prompt to write the cover letter. Okay, so you are an expert technical recruiter and cover letter coach specialized in you pass the job description, so it needs to know the job description as its area of specialty. All right, and then all the necessary details we need to give it, both how we want the structure to be. Now look at the structure. One is the opening. The body can be 2 paragraph max. Okay, where it talk about 2 to 3 of your strong match from the match map. All right, remember we'll be passing the match map, and then the closing should be 1 paragraph. So this is how a standard cover letter should look like. So that's why we're passing it in the prompt. Now it's no more just passing the string from the job description and then your resume and then telling it write resume for me, but this we are passing structured data. Okay, we are passing structured data, and then the match map, which is showing it your strength. So with this now, it will now be able to now emphasize more on your strength and your weakness. And then the aim is between 250 to 400, but we're interested more, it should be 300 to 350. This is more better. All right, so and then we are passing the schema of the type of response it should give us, which is the cover letter draft. So I'll run this now, and then the structured output with the LLM. So now this is our writer agent. Okay, so this is the node. It's very straightforward. We are getting all these data from our states, so we don't need these two. We can leave them here, we can have them here, we don't need them. So but we are getting, these are the ones we need: the past resume, the past JD, the match map, and then the job title. The job title is coming from the past JD.job title. Okay, then we get all these details, then we construct our system message. Remember our system message, we're only populating this schema, which is cover letter draft dot model JSON schema, and then we're passing the job title, which is what we have here now. Okay, then this is the human message. Okay, so we are saying that we're now adding in the human message, we're adding the past resume, this is the past resume, the past JD, this is the past JD, and then the match map, and we're now instructing it write the full cover letter. So we've passed all the details we need in the messages, so it's not left for the LLM to take over. All right, so now here, now we are now invoking the LLM with a list of messages, use the system message and then the human message, and we are getting the response, and then we are updating the draft letter with the response. Remember, this response is a type of cover letter draft. All right, then we build our graph. Very straightforward. Okay, the state schema is the cover letter states, and then the only node we have here is the writer node. Great. So we are going from start to writer, from writer to end. Very straightforward. So let's run this, and then also draw the graph so that we can see it. So this is the graph, very straightforward. From this to this, from this to this. All right. So now here, now we are invoking the graph. Okay. So we are passing the resume test, the job description test, the past resume, and then the past job description. All right, and then we are passing also the match map. We are getting all this from the result of our last graph execution, which is from result 1. Okay, so and then result 2 now, which will not be the output of this particular agent. We are saying that the writer agent.invoke, and we are passing this input. So if we run this now, so and this agent is done now. Okay, so if we look at what it returned, you see that the cover letter draft is here. All right, so now let's look at the cover letter. So to get the cover letter, we say that is the result draft letter dot full letter. So this way we'll be able to access the cover letter. So if we run this, you see that this is the full cover letter. And then let's look at it and know if it was actually well structured. So it says, dear hiring team at Neurotech Innovation, I'm excited to apply for an engineering position at Neurotech Innovation with over 5 years of experience of end-to-end AI development, spanning generative AI, computer vision for agriculture, and ethical AI governance. I have consistently developed production-ready solutions that scale across cloud. But you see that the first paragraph is already well structured, and then look at the second paragraph where it was talking about the roles he has done, or the candidate has actually done in different companies. These two talked about the role the candidate has done in different companies he or she has worked. So you see how well structured this is, and then this is the last paragraph, and then closure. So you see that this was well structured, not too long, very short, and then neat at the same time. So this is the type of data that this is the type of cover letter that you might need to do or to submit to a particular company, and then they'll be able to look at you very well. All right, so having done all this, you see that our code has just been scattered around this place. So we are going to build our agent together now. Okay, so we're going to build the agent together, having understood how the different agents we are working to achieve their aim. So let's build the complete agent here now. Okay, so we brought all our schemas here. So all the schemas are here. All the schemas that we made use of are here. And then this is the state schema we'll be working with for the entire agent. Okay, so these are the different state schemas. So the resume, the job description, past resume, past job description, the match map, the cover letter, that is the draft cover letter, and then the feedback, which should be a string, and then the condition. All right, so this condition, we're making use of this condition. Okay, so this condition now is we're going to be using this condition whenever there is a feedback. So look at the state here. So it should be returning a boolean data, a true or false. All right, so when we're working with it with this feedback, remember I told you that we are going to be working with a human in the loop here now. So when the user gives an instruction, so the agent will determine whether the user wants to continue or stop. All right, that is what we'll be needing, the true or false in the condition. Okay, so and in the match map, I added few other data in the match map. All right, so we added um, this strong match and then the explanation. So it will be able to, we'll be able to return a data back to the user if he or she is a strong match, and why, before we continue to write the cover letter. So if we go forward, you will see how that was done. But these were the two other keys that we have added in this match map. Okay, so and this is the schema. So we'll run this, and then we'll go over to initializing our LLM. But this was the LLM we used before. Initialize the LLM, and then these were all the structured data that we had earlier. So all of them are here. Okay, and then this is all the prompts that we made use of. All the prompts we made use of earlier, all of them are here. And then this is our graph now. So we're going to go over this graph one after the other so that we'll see all the nodes that we'll have here and what changed. So the past resume is the same thing, nothing changed. We'll have the past JD, the same thing, nothing changed. Then this is the matcher node, nothing changed in the matcher node. All right, and also this is the writer node, nothing also changed in the writer node. It remains the same thing. All right, then let's look at the check feedback. These are the two functions that were added here, the check feedback and then the condition loop. Okay, the check feedback takes a feedback, all right, from the state. It takes the feedback from the state, now pass it to the, using the feedback prompt. So we'll have the feedback prompt there, using the feedback prompt, pass it to the LLM to get the feedback. All right, so and it updates the state with the condition. Remember, it's going with this condition LLM, and the condition LLM is the type of the condition which I showed you above. Okay, so and that condition holds either true or false, so it updates the condition state in the state graph with that particular condition. Now this condition loop is the loop to now check if condition is true or false. Okay, so it takes the condition, okay, to stop, then it check if the condition is true, it returns end. If the condition is false, it returns continue. So what this does is if the user says I want to end, it will return true because the user wants to end. But if the user say I don't want to end, it will return false. All right, then I'm going to show something up here. There is a little thing that changed in our okay, no, nothing changed in the matcha agent. All right, so what we are going to be doing here is this graph is going to run this way. Okay, so it will run from the matcha, that is from the analyzer agent to the matcha agent. Now after the matcha agent is going to return some output to the user. All right, then the user will now decide, oh, I am a strong fit for this job, generate the cover letter. Oh, or I am not a strong fit, abandon mission, don't generate anything again, and then the agent will be able to end. So let's build the graph and let's see how it goes. So this is we're passing all the nodes from the parser nodes to the resume nodes to the job description parser node, then the matcher node, and then the check this feedback node, and then the writer node. So now we are building the graph. So from the resume parser to the JD parser, from the JD parser to the matcher, from the matcher to the feedback. All right. So this feedback will be able to take a feedback from the user. All right. So I've also made a video explaining how a human feedback is being taken from um, uh, why a graph is running, so how you can implement a human in the loop. So I will also link the video in the description of this video so that you can actually watch it and then see how it is being done. All right, then after the feedback node has executed, we'll be adding a conditional node. Okay, so it's going from feedback to this conditional loop, which we designed here now. So this conditional loop will be returning two things. It will return end or it will return continue. So what we'll have here, if it returns continue, that means the user wants to continue. Then go ahead and generate the cover letter. But if it returns end, go ahead and end. So that's what we'll have here. And then when now if it returns, if you now went to write, then go from write to end. All right, then we'll be adding a memory, we'll be adding a checkpointer because we are going to be giving it a feedback so that we'll be able to assess our state. Okay, by using the in-memory checkpoint. Then we are passing the interrupt. So where do we want the interrupt to occur? We want the interrupt to occur after matcher, before it gets to feedback, so that we'll be able to now process whatever feedback that the user has given to the agent. Okay, we want the interrupt to occur at the matcher, after the matcher node. Then the interrupt should occur, and then we are passing our memory. All right, then let's build this now so that you can see the graph. So now look at how the graph is. Okay, it's quite long. So we're going from the past resume to past JD. From past JD, we are coming to the matcher. And after the matcher, the interrupt should occur here. All right, this is where we'll pass our feedback. And then once we pass our feedback, we'll process the feedback. Then the feedback should return continue or end. So if it returns continue, then you can write the resume, but if it returns end, then end the execution. So this is just a straightforward way that this particular agent can actually work. So when you look at it now, you see that it's actually a multi-agent that has multiple steps and then has different decisions based on the human feedback. Then let's now run the agent and see how it goes. Okay, so these are our job description. Same with the job description we had above. So we'll run this. Then we're going to use our resume. So this is the value of the resume we used above. So if I print it, so we still have it here. So that's the resume we used above. And then we can invoke our graph. Now invoking this graph is very straightforward. Remember, we are invoking the entire graph. All right, so we are passing the query, and the two keys that are necessary to invoke the graph is the resume test and the JD test. Those are the two keys very, very necessary to invoke the graph. All right, and then we are passing our config, which is configurable thread ID, and then we are passing our thread ID. And we're saying response is equals to graph.execute, graph.invoke. We are passing our input and then the config. So let's run this now. So it's going to take a while so that each agent will be executing one after the other. So now the graph is done. All right, so let's look at the response. So this is the response. You see that we already have the resume test, the JD test, the pass resume, the pass JD, and then we have the match map. We have everything here already, but it has gotten to where we have the interrupt. Okay, so for us to know the next node that was supposed to execute next, we'll say the agent.getState will pass the config and then we'll pass next. So let's look at the next nodes. So you see that the feedback node is the next node that was supposed to execute next. So there has been an interrupt, but we have our match map. All right, so from the match map, let's look at the data we have from the match map. So this is data we have from the match map. So we should be interested in these two. This is the data we should be feeding to the user. If there is a strong match, yes, and then these are the explanations. So since this person is a strong match, we can now go ahead to tell the agent to go ahead and generate the cover letter. Okay, and if we also scroll up, we see that the score here is high, also 85%. So that means that resume is a strong match. Then we can now pass a feedback saying generate the cover letter. So we're going to pass in this feedback to generate the cover letter. All right. Then we're saying agent.update state. We are not trying to update the state, okay, with this value. We are populating only the feedback key. That is the key we need to update. And then we are passing the config and as node matcher. So we are doing this, we are telling it update this state like it was being updated by the matcher node. All right, then we can run this and then it will update the state for us. And once the state has been updated, we can now go ahead to now invoke the graph. All right, we are now passing none as the input, and we also passing the thread so that it knows the thread it needs to execute. So we now run this. All right, so and our agent is done. So now let's look at the result we have. You see that, yeah, the condition here was actually false because we didn't want it to stop. Okay, we wanted it to go and continue to generate the cover letter, and then it was able to generate the cover letter here. All right, so now we're now printing the cover letter. Okay, response of draft letter dot full letter. So we're interested in this full letter, and then we'll be able to look at the full letter. So we see that we have the full letter. Now running the agent as a full agent. All right, so this is the full graph that is working now. So we've been able to develop the full graph here now. So the next we're going to do now is to now transfer all our code as a Python file, and then we'll be able to build different endpoints so that if you deploy this code now, someone from anywhere can actually make query to the agent and then get different feedback. So we're going to see how this will be done. So we're going to start pushing them and then building different endpoints to get this thing to be done. So to get this thing done, so we need to import a couple of other libraries. Since I want to build endpoints, I will be working with Fast API. So I'm going to go back to terminal and then install Fast API. So people install Fast API. All right, so we've installed Fast API. Then I also need to install UVCon, which is the server we'll be using to run this our server that we are building. So people install UVCon. So people install UVCon. All right, so we're now set to now start building the endpoints. Okay, so I'm going to be creating a folder here. I'll call it my source SCR. So and I'll be creating the first file here, init.py. So the essence of this file here is actually to make this folder a Python package. All right, then I need to create other files here. I will create prompts.py. Okay, so that I will pass on my prompts here. I will create schema.py where I will pass on my schema.py where I'll pass on my schema. I'm going to create utils.py where I'll pass all the utility files or the utility data, and then I'll now create agent.py. So this is where I will now pass my full graph code. All right, so I will now start passing all the necessary data we need here. I won't be putting anything in this init.py. All right, so we'll start with the schema. So let's go up and then copy all our code. I don't need this any longer. I scrolled up a lot, so first of all, I'm going to copy all my schema from here now. So all of them. I'll go to schema.py and then I'll paste them. Okay, and then I'll save this. Then I'm going to copy all my prompts. So I'm going to copy all my prompts and then copy this, come to the prompt.py, paste all this and then save this. All right, then now for my utilities, I'm going to for the utilities, okay, let me copy this. Um, okay, so I wanted to copy this. So come to utilities, paste this. Then let me take out all that I don't need here. I don't need these ones. So here now I'll be defining all the LLMs that I need. All right. So I'll come back here. I'm going to pick all these ones and then pass all of them in the utility. In the utils file. So I need to pass all of them here. So now I need to import some of these schemas here now as well. So I'm going to go from src.schema and then I need to import all these schemas. So I need to import the the resume schema. I need to import the JD schema. I need to import the match map. I need to import the cover letter schema, the cover letter draft, and then the condition. Alright, so I've imported all the schemas I need here. So I think this file is good to go. Alright, then I now need to copy all my agent data to where I built the agent. So I need to copy all these data here now to this point. Copy everything and then paste them here. Alright, then I will need to now import all these files and then make this to be good. Alright, so I need to import from both the prompt and then the schema. So from the schema, let me import all the necessary data from the schema. So I'll say from src.schema, I'll need to import the state schema first. Okay, my import is not correct. So I'll need to import the state schema and okay, let me import the prompt from src.prompt. So I need to import all the prompts that we need here. So starting from the resume prompt, so I need to import the JD prompt. So I need to import the matcher system prompt. So I need to import, let me see other prompts that I need here. Okay, the writer prompt and feedback prompt. Okay, so the writer prompt and then the feedback prompt. All right, then from the schema, there are other schemas I need to import. I need to import the JD schema, the matcher schema, and the rest. So I need to get the JD schema, the matcher schema, that is the match map. We need to get the resume schema, and what other schema do I need here that is missing? Okay, so I need to the cover letter draft and then the condition state. Okay, so we'll get the cover letter draft, then the condition state. All right, then now I now need to import every other data that the agent needs to work, which is um, from LangGraph. I need to import the state schema, the state graph. Okay, from LangGraph.graph, from LangGraph.graph, I need to import the state graph. I need to import the start. I need to import the end. So then from LangChain core, so from LangChain core.messages, I need to import the human message and system message. All right. Then I need to import my LLMs as well. So I'll say from src.utils, I need to import the LLM and all the LLMs that we use there, which is the resume LLM, the JD LLM. So let me see other LLMs that we need here. The matcher LLM, writer LLM, and conditional LLM. Okay. So need the matcher LLM, the writer LLM, and then the condition LLM. All right. Then let me go through and see other data that I'm yet to import. So I'm going to update all this. I'm going to update all this. Okay. And okay, we need to import literal from typing. Okay, so here now, so from typing import literal. All right, so I think we're almost there. Okay, so here now, this particular function is under the matcher node, so we're supposed to be taking this from the states and this also from the states. And this also from the state. So I don't think there's any other importation we need to do, any error we need to correct in this particular file. So our code is clean now. Now everything we have here is our function. So also I'm going to pass this my graph as a function. So I'm going to pass it as graph. I'm going to say define graph. So it's not taking anything, and then all of them should be a function, and then I am returning agent. So whatever that I compile here, I'm going to return this. So I'm going to make another importation here. So I'm going to say from LangGraph dot graph dot this should be dot state. So I'm importing compiled state graph. So compiled state graph is the type of data that I need to be returning here. All right, so I need to pass it here. Compile state graph. All right, so with this now, I'm done with my graph. So I can save this code, and okay, I'm done with this. I'm done with my graph, so I'm done with the data here. So I have my prompt where all the prompts now reside. Okay, so I didn't import anything here. I have the schema where all the schemas reside. So the basic data we need here is the Pydantic, and then from the typing, I have the utils where all my LLM data resides, and then the agent where all my agent data resides. So I'm going to now build the endpoints. Okay, to build the endpoint, I need to create a file at the base here, which will now be my main.py. All right, so my main.py. So at this main.py now, I'm going to build all the endpoints that I need to access this data. Okay. So first of all, we're going that from fast API import fast API. We're going to import, say, from sroc.agent. We're importing the graph, and okay, we need to build few schemas that we're going to be using for our endpoint. So the schema for both the data input and also the data output. Okay, so we're going to go to our schema now to define those schemas. So we go to our schema. We need to define few other schemas here. All right, so and each of them is going to be a Pydantic model. So the input schema. Okay, so this is inheriting from the base model, and we'll have the resume, a string, and we'll have the JD, a string. So this is the schema to pass input to a particular endpoint, and then the output schema. The output schema is taking the message, which is a string, and then the last one, which is the schema for updating the graph, which is inheriting from base model as well, and then we are passing also message, which is a string. All right, so these are different schemas we'll be working with. Okay, so we need to import them here. So from sroc.schema, we need to import the input schema, the output schema, and the update schema. All right, now let's go on to now build our endpoint. So we have two endpoints. All right, so the first endpoint will be responsible for invoking the graph, and then second endpoint will be able to send update. That is when the user sends a feedback. So let's go ahead and then build our different endpoints. So we need to say that the agent is equals to graph. Now, while we are calling this graph, you know that this is the graph that we defined here. That is this. And this returns the agent we need to work with. Okay, so once we call graph, it's going to come and call this function and then return the agent. So we now have everything we need to work with here as the agent here now. Okay, so let's create the instance of our fast API. So we've created the instance of our first API. Now let's start creating the different endpoints. So the first endpoint is app app.post. All right, so the name of the endpoint is right, and then the response model is the output schema. All right, then let's clear the function. So this is async define write cover letter. So, and it's taking the data from the user. So the data is going to be a type of input schema. All right. Then from here now, the user has we've gotten the data from the endpoint. So we now need to constitute the query. So the query is going to be equals to. So inside the query, we'll be needing the resume, which is the resume text, and then the resume text should be data.resume, comma, and then we're passing the JD text, which is data.jd, and then we will invoke our graph just the exact same way we invoked the graph here now. Down here, just the exact same way we invoke the graph. So we'll be able to constitute this. So we now need to constitute this and then invoke the graph. So I can copy this line of code here now, and then here now, and then we can pass it here. Okay. So this is the config and this is the graph. So we are actually invoking the graph here. Then we need to construct the response we are going to send to the as an output. Remember, when this executes, it's going to stop at once it encounters an interrupt. That is after the match map. Okay, so we need to construct a message, and the message that we are sending, when you watch this, you see that we need to send so look at the match map. We need to send let me scroll down. So we need to send, if the person is a strong match, we need to send yes, a strong match, and then with the explanation. So I did something here, so we'll have this here now. So I'll copy this and I'll paste it here, then I will explain. Okay, now what happened there now is we are checking the match map dot if the strong match, that particular value that holds the true or false. So if the person is a strong match, we are now returning you are a strong match with score. We are passing the overall score, and then we are now passing the explanation from the agent. Then if you are not a strong match, we are returning you're not a strong match with the score and then the overall message from the agent. All right, so at this point now, we're going to now send the response from our endpoint. So we're going to return MSG. No. This should return a dictionary. All right, so MSG response test. So with this now, we'll be able to invoke this and then it will send a complete and comprehensive response. All right, then let's build the second endpoint. So the second endpoint will now be to send an update to the graph once it has started. Okay, so we'll say is slash update, and then the response model is still output model, output schema. Okay, then async define update graph, and then the data is the type of update schema. So an update schema, what we'll have here, it has just the string, which was the message, which was the feedback from the user. All right, so we're now going to build our agent. Okay, remember we need this config. We need this config, and then our response now will be, say response is equals to our agent.invoke. We know that anytime that this particular endpoint is being called, that means the agent has been invoked earlier on before. Okay, so before we will say agent.invoke, we need to do what? We need to update. We need to say agent.update. So I can come here and copy the exact thing that we did here earlier. So we can update this. Okay, we'll copy this, and then we'll come here, we'll drop it, and okay, so this feedback now should be equals to the what we got from the feedback, which is data.feedback. All right, so data.msg, we get the feedback, and then we are updating um the the agent here now, agent.update. We are passing the config, the value is feedback, we are updating with feedback, and then as node matcher. All right, then we can now invoke now. So our input is equals to none. We are passing config. We are passing config as config. All right, and that is it for the agent. And then we'll be able to run this agent. So when we run this agent now, so let's go back to what we did here, so that we follow with what we are actually doing. So if the condition is true, it will not return a draft letter. But if the condition is false, that means it will return a draft letter. All right, so now let's come back here and construct the message we need to send to the we need to send as response from the endpoint. So we have response. So we say if response of condition. So let's look at this again. It's condition, right? Condition, great. So if response of condition, if this is true, then we need to return that the cover letter was not generated. But if it was false, else, that means the cover letter was what? Generated. So we're going to get the cover letter from the agent response. So we're going to say response. So this is how we got the cover letter here. Okay, so I can actually copy this and then paste it here. This is response, not response one. So I can take it as the cover letter is equals to this. All right, so the cover letter is equals to this. Then here, if this happens, that means the cover letter was not generated. So I can say cover letter is equals to, I'll say no letter was generated. No cover letter was generated. Then with this now, I've gotten the full cover letter here. So what I need to do now is to now say return and we're having MSG, and we're updating it with whatever we have in the cover letter. All right, so at this point now, our endpoint is done. All right, so we'll define the first endpoint to get to, first of all, invoke the graph, and then the second endpoint to update the graph once it has started running. All right, so what we now need to do is to now run our endpoint. So we open our terminal. So I'm going to create a new terminal here. Okay, and then okay, it has started our visual environment. So to run this, I will now say uvcon main app reload. All right, so let's run the endpoint and then see what we've got. Okay, application startup complete. So it has started in on the local host, which is 127.0.0.1 at port 80. All right, so to get feedback from this, I'm not going to be using Swagger UI today. I'll be using um, a library from Python called request. Okay, so we're going to be using a library from Python called request. So here now I'm importing request, and then this is the base URL. That's the base URL. Okay, so I can run this, and then this is our payload, which is the first request that we're making. Remember, we already have the resume defined up here, and then the JDO defined. Then we're passing it to this payload. Okay, and the endpoint we want to talk to is the base URL dot slash write, which is this particular endpoint now. And then this is the input schema. And the input schema here now takes the resume and JD, which is what we have defined here. Okay, so we just say that response is equals to request.post, because this is a post request. We say app.post is a post request. If we said app.get, then it's going to be a get request. All right, app.post, and then we are passing the URL and then the complete payload, and then we are printing the response that we got. So let's run this. All right, so it returned 200, so that means it returned an accurate response. So let's now look at the response dot JSON, and then we are looking at the message. All right, which is this is the type of data it returns. We are looking at this. Okay, so we'll see what it returned. So look at what it returned. There is a strong match with score. It's 8.0%. The candidate, and then it's now explaining how the candidate is a strong match. All right. So since the candidate is a strong match, you can now make the next request. You can now say continue to generate the cover letter. All right, and then this is the next request. So we can now make this next request so that it will then generate the cover letter for us. And we also return 200. You can see the response at the terminal here, and then let's now print what we got from the response. And okay, it said no cover letter was generated. I think this is an error, so let me go back to our endpoints. I think we made a mistake here, so let's look at this again. So I think let's go back to our graph and check what we actually did here. Okay, so let me minimize this. So at this point now, if this is true, then it should end. That means no cover letter was generated. Okay, let's let's um let's print this on the console and let's see what it has, and then we'll run this again. So because if it generated a cover letter, we are supposed to have false here. Okay, this is the problem now. Okay, so we are supposed to be getting from the condition we say dot stop to actually get the actual data here. So I've seen where the issue is coming from. So we need to say dot stop because this condition is a type of this. So this is where we have the error. So we'll say dot stop to actually get the value from there. So this is where our problem was from. But I can still leave this print statement here. So this is um, how troubleshooting works. So when I save this file now, our code started rebuilding at the endpoint, okay, because of this parameter we passed here, reload. So application startup complete. So it's now complete. So we'll go back and then invoke our endpoint again from here now, from what we did before. So we're going to run this and then run the second one. So let's run this again. All right, this is successful and we'll have a 200. Okay, so let's print the response, which is the message. Okay, so and it's saying that you are it's 7% match. So let's run this now. Okay, then let's print the message. Okay, you see that now that a cover letter was actually generated for this. So with this you can actually understand that we were able to start the agent and then update the state through the endpoint and then to be able to get us the response. So this is basically how this will work. So next we're going to building a user interface. We're going to building a user interface which will enable us to interface to this endpoint. So we'll be building a user interface right now. So I'm going to create a Python file here. So I'll call it ui.py. All right, so we'll be building a user interface using Streamlit. All right, so I have a little code here which I'll copy. Okay, let me get this. So this is a Streamlit code. All right, so what we need to do here is to also install Streamlit. So we'll come back to this other terminal and we'll say pip install Streamlit. So, and this is going to install Streamlit for us. All right, so as Streamlit is installing, let me walk you guys through this code and then you can actually understand what is happening here. All right, so this function that I defined there is the function to be making the request to the endpoint. All right, so we are using the request library to do that here. Okay, so okay, this is the base URL. Let me take this up. I would like this to be here. Okay. All right. So I'll give us a little walkthrough. Okay. So here now we are setting the title and then this is the base URL. So these two now are getting these two values from the state. In StreamRead, there's what we call the states management so that it can actually know the current state of the user interface before you refresh it so that it can update both the messages which will be showing on the screen and then other values that you have there. So I have a value started which is supposed to be false. All right, maybe in subsequent time I will make a video on how you can actually use Streamlit. All right, so here now I added a sidebar. So these are the places we should be interested in. We should be interested in the sidebar. That is one of the places for uploading the resume. Okay, so from the sidebar I uploaded the resume. I'm picking only PDF files, and then when I pick the file type after upload, I now use the PDF reader to open the file. all right, and then populated all the text inside this resume text. So all our resume is inside this resume text. Then the next place we should be interested in is here. Now when we take input from the chat message. Okay, so when we take input from the chat message, from the chat input in the user interface. Okay, so this way you take input. So when there is an input, it's being stored in this prompt. So first of all, we print it on the user interface, and then we'll now take it to make um, to send back to the endpoint, to the different endpoints. So we are checking two things here. If the agent has started earlier, if it has started before, then you need to update. That means you are trying to update, all right? But if the agent has not started, then you are going to start the agent for the first time. So you are starting with the right endpoint, okay, and then passing your payload, which is your resume and your JD, and then you are calling the make request function, which was defined there, and then making the started true. But if the agent has not started for the first time, if the agent has started for the first time, you are calling the update endpoint, okay, and then this is the payload, which is the message from the user, which will be used to update the graph, and then you are calling the request function, which was created. Okay, so now let's look at this request function. You see it takes two arguments, two parameters, the URL and then the payload. Okay, so and we are using it to make a post request and then returning the message that we have. So I'm going to save this, and then I'm going to run this Streamlit app, and we're actually going to see how it works. Okay, so let me create a new terminal here. So and then I will show you how you can run the Streamlit app. All right, so to run the Streamlit app, what you need to do is to type Streamlit run. You pass the name of your app, which is ui.py. All right, so once you type this and you hit enter, it's going to run the Streamlit app, and it's going to run it on our web browser because it's a web app. So we give it some time to start. So it has started already, and so this is the app. So it's starting on localhost port 8501. All right, so this is just how the app looks like. Okay, so this is how the app looks like. This is where you make input, and then this is the sidebar to upload the resume. So what I'm going to do first of all is to upload the resume and then paste the job description here, and then we'll invoke the graph. So first of all, let's upload the resume. If you click this button now, it's going to open the file explorer so that we can get the resume uploaded. So trying to get the resume. So this is the resume here. So and it has uploaded the resume successful. So at this point now, it has loaded the complete resume data. So let's go back and get our JD. So let's get the job description. I think it's somewhere here. All right, so this is the job description. We copy the entire text. So I copied the entire job description text, and then come back here, and then I'll paste it here, and then I can now click enter. Okay, and then it will start running. So wait, once we get a response, it's going to print the response here, the first response that we got, and we'll be able to communicate with our agent just from this user interface. All right, so this is the output we got from the agent. Okay, so saying that we are a match. All right, then we can easily say go ahead and generate the cover letter. So, and as you can see here, it was able to generate a good cover letter for us, and then which you can easily copy and then now paste it in your work. So this is just basically how it works with the user interface. So in this tutorial today, we have covered how to build the cover letter agent, how to build different endpoints to communicate with your agent, both making the query and then updating the agent state. At least you've seen how to manage the agent state from an endpoint, and then how you can walk through a user interface. All right, so if you like the video so far, give us a thumbs up and subscribe to this YouTube channel. We'll have tons of quality videos for you on how you can build AI agent. Thank you very much for watching this video. Meanwhile, keep coding. See you in the next video.